Hi, welcome to our presentation for 4900. Today, our topic was Signalyze. It's a program. It's a project we did throughout the semester. Our teammates are Marco Chen, Rigoberto Pons, and me. So our project overview is Rigoberto doing text-to-speech, and my teammate Marco Chen doing the gesture hand mark detection sections. So here is our recapitulation of our presentation nights, and this is us.
Can you zoom in quicker?
All right, now let's start with the presentation. So we first go through planning. So Rigoberto worked on the text-to-speech documentation and recommendation for project Hugging Face and Streamlit testing for text-to-speech and project suggestions. The Marco worked on OpenCV, sign language training, data collection, local testing, and implementation on Streamlit. I'm working on smaller projects such as H5 training to testing different platforms for usability and put the project together. Integrating text-to-speech, OpenCV, and also working on exploring Librosa for future app augmentation. So today's presentation format going through like this. First, I will introducing a voice processing testing. So this is the most important part of my learning, where I learned all the stuff from this video processing for music and also for how to train H5 file, train different data. And the second stage is like I'm gonna testing Librosa and its uses on music analysis, which will lead to my understanding of voice processing, which later on help me integrating this text-to-speech and for the integration of the sign language and text-to-speech and to understanding basically how this voice-to-speech things and the audio handling work. So the third step was introducing an image processing and then video processing and then talk about platforms and failures. And the last steps we will present our project and also a recapitulation of our presentation night with my teammates. So now let's introduce my work and for the project. So for my part, my contribution was planning. So Rigoberto and Marco Chen have formatting a documentary to listing what do we need to use for this project, and I'm gonna plan and making smaller project to make each step work, and then we put the things together, similar like how do you build this like puzzle things. So the first thing is understanding basic steps, and then once we understanding the basic concepts, we can finding different resources and the coding and testing. And then the testing platform including Unity, Flask, Hugging Face, Streamlit, Amazon Cloud, and also Render, Heroku, and also various different platforms for app implementation. Experimenting on Librosa and currently in progress. And these things make it work tonight actually. It's a small personal achievement. So the problem statement. The sign language is a crucial communication tool for the people with deaf and hard of hearing communities, but many people are not fluent in it. So bridging this gap through technology can enhance this inclusivity and accessibility. So that's why we come up with this idea about using OpenCV to recognizing hand system. So our solution is first we process a system that can capture sign gestures and using a camera, and then recognize gestures through machine learning models, and then convert this gesture to a different text and text-to-speech in real time. So the technology we use is OpenCV, which was like a real-time video processing app, and also MediaPipe was really helpful, like introduced by Hussam, and also its hand tracking and gesture recognition system. TensorFlow and Kalias is handling deep learning and model development. And finally, we're using Python libraries to using this text-to-speech and NumPy and also Flask. So my first step, starting with learning something small. So handling voice is the most important part because like we have to go through one-dimensional to three-dimensional. So the voice is the basic part, and then the image using this CNN formats and different formats. And then after voice and the image, we go through video and integrating how video and the voice can integrate together. So for me, music study is part of my specialty, like in this small project. So I'm using music study and voice handling inspired by Khugzhem's repository for emotional recognition system. To start this project, first let's go through Khugzhem's really amazing repository. So Khugzhem is our teaching assistant, which has been really helpful, and he's so great. So they are doing something using machine learning and Librosa to recognize different speech and generalizing emotions. So using this emotion to detect other voices using this machine learning model. And what I learned from this really amazing models, like they're using inspect and explore data and selecting engineering features, build and train models, and evaluate models. So basically, they import different libraries and using machine learning to learn things. And they have this PyDupe to presenting audio segment, audio that can be manipulated using Python code. The first step is inspect and explore data. So they train you with really great data, like from Kaggle. But for me, it was like I want to learn something about my own music, so I doing my own style of training. I will show you later. So the importing data sets is another issues, because like they always have formatting issue things, and preparing data and readiness. So this part was basically dealing with data labeling, data cleaning, and data like preparation. But for my part, I don't really need those things because I label my own data. I know what's my emotion, so I put into different folder and then just check later. And then preparing data for creating this data set. This is another step. And after you labeling different things, for example, female, male, and neutral emotion and all those things, then you replace different kind of like a typo things. For example, replace female with female and this type of things. But for my case, I doing with small data and my own data, so it doesn't apply. So their project is more ambitious, but our project is a little bit smaller. So yeah, then they're using data visualization. Currently, I don't have this feature yet, but my own data was only dealing with 6 different prototypes. I will show you later. Yeah, so basically, they are using Librosa's domestic learning system to mapping this different type of waves, and then you learning this different type of things, for example hertz, and also like the seconds, so they can study this type of things like to recognize a different pattern they haven't seen before, so use these things to predict things. And this is a really great system. And for this spectrum things, I already seen these things during Professor Cohen's class with electronic music last semester. So this is also another very interesting thing in learning different sound. Yeah, so basically this is the idea, and this is from Khugzhem's repo I learning extensively. And now let's going back to this learning process. So the learning FFmpeg is another formatting thing. So this formatting can convert in between MP3 to waveform, because waveform is bigger, not bigger, like more specific. MP3 is smaller. And then I also learning so many things with Professor Cohen on this timbre things and how tempo things and how this electronic things going through this. Other things I forgot was the software. It was the software that you can paste track there and they reflecting different like pictures. And also, labeling my own data is another process. I label my own data. I'm going to show you my basic data labeling things going on. So for my small project, I have this music data. So all this music, I pick up different music I composed during the past 3 years, because I know those styles are unique to me. So I label them as different labels and then put this music style in there to learning from. So that's how I label my own data. And then supposed to be generating a CSV format to recording this data point. For example, they're using different software to extracting tempo and chroma, and also those like picture line things. And then after this process, we can generating an H5 machine learning model, and they're using this model to predicting other things. So now let's going back to topic. So what is FFmpeg format? FFmpeg is a powerful open source tool for handling multimedia data. It can convert audio and video formats and then resample, re-encode and normalize this audio file. So basically, for my case, it's like converting between MP3 and WAV, because like the WAV sound format was better with a better quality, and it's easier to extracting this music information. So for handling unusual audios, yeah, there is like when we're dealing with data learning, when we're dealing with this machine learning and data labeling, there will always be this conflicting things, and they will result in the file is not reading into a CSV or don't recording correctly. So for me, it was planned to force read all files, and there's a process I learned called fallback mechanism. It's like if a feature have this tempo, MFCC, and chroma, so basically there are different wave recording different wave things. If it fails and has unexpected dimensions, these dimensions things that in my best knowledge is like array. So for example, if tempo only have one array, and then the other format have two array, so these things will not match. So I have to force into some data into it. So for my solution is like, for any problematic file, ensure that output has consistent dimensions. This is the first issue. And if something, for example, like electronic music or from some of my music have this really weird tones, they will not be recognized, then I put it as zeros on alternative placeholder. So this zero is still valid because when they read through this data, they will still recognize a pattern and use it to predicting other patterns. And no skipping, so sometimes they skip these files when it's not working. So we have to write the code saying this log issues must be like continue processing every file to make sure every file have recorded something. Even if something was not showing there, they put a zero there instead of like skip this whole file to mess up this whole files. And the next stage is called debugging. The debugging files usually have this uniform shape for all features. So it's basically, they have tempo MFCC chroma is reshaped to fix this dimension. For example, tempo has 1 row and MFCC has 13 rows and chroma have 12 rows. So I will skip this process. This is another like kind of like professional discussion. So this is my backlog. So the biggest issue I might was this like something called dimension thing, because for example, these things when they produce reading my one of the piece, Professor Zerio's like reference or experimental things, they don't have the same dimensions, but the array in the index 0 has 2 dimensions and the other has 1. So I have to, that's why I went through this process to force everything through, and eventually this thing will read. For example, they say tempo shape is 1/5000 and the MFCC shape is 13/5000, the chroma shape is this. Like all of these things will give you a number, and this number is supposed to convert into CSV, but CSV failed. I'm going to explain why. Because there are file types. The NPY is a binary file format specific to NumPy and also optimized for strong arrays for metadata. For example, this strong arrays, and this is why I'm going to skip this thing, you can read later. So for analyzing why my CSV file didn't work. So why it didn't work? Because our features have multi-dimensionals. For example, 26/5000, which is CSV can't handle these things like by itself, because CSV was like 1 dimension. So for fluttering those arrays into a CVS would lose the structure integrating in this data and complicate the processing and model training. So that's why we are using NPY structure instead of this structure. And Marco also come up with other different structures, which is really great for his final hand recognition system from MediaPipe. So now let's go to the next macro step. Now we produce our first NPY format. This just imagine it's similar as CSV. So they're listing all this data, like which is this form, what is this point, what number is it? And we can now train H5 to recognize those patterns. Now we plan for training the models. The training the models first will load, and the dataset load the NPY file separate these features and label them. And then we train them, split into training and testing side. And after these things, we'll be able to produce a H5 file. So how it works. Basically, the model learns patterns from these input features. And those features capture key characteristics of my music style, such as rhythm, tone, and timbre, and all those compiled from this chroma packages. So this is my 6 different style. I call it avant traditional, clandestine, and correct classic canon, innovative, existence, plus noir, and the referential, experimental. So each have the different ideas. They doesn't exist in any other style. So after learning my own pattern, they will produce 6 styles labeled as 0 to 5. Now I make it into an H5 file. So now we're going through this training process using neural network mapping to capture this pattern. So now we have this H5 file using my CSV, which was MPY file, like the 2-dimensional things. And then they will give you a H5 file. This H5 file is the most important part of any model training, because usually other people will train from tens of thousands of files into this H5 file, so people can borrow this model to train their own model. And this is I learning how to do these things from scratch, because I really like Khugzhem's idea. Like back then we don't have Hugging Face, we don't have all that, we have to train by ourselves. This is why I really like these things. So I start to train things by myself. So not every H5 file will end up in success. So there was only 2 working. One is this, the other one was the handshake. I'll show you really quick. Now let's testing these things on Streamlit. So here is my project. Let me show you. See? Now they will show you this 6 style, right? And then you drag a random video with either MP3 or WAV, and they will analyze which of these 6 style integrating with each other. For example, let me put my own music there. For example, let's put something regular. See? Now it's analyzing based on my H5 file. And what it will produce, it's predicting, like we have this 7.4% of this style. They will using this pattern to recognize which 6 style will integrating with each other. So they recognize my this piece was most close to this pre-noir style, which was 32. So this is how it ended. So innovative existence 36%. So they were learning how different music style correlated to each other based on this pattern. And this is my personal achievement on these small things. Sorry, I forgot how to. Yeah, let me stop here. Now, let's back to the main project, section 2. So the section 2 is image processing and media pipe for video processing, exploring media pipe and hand tracking, and analysis different data using training method. The method we use is data preparation, data training, and real-time integration. So what fails is Gav.Khugzhem Unity. I will not show it here because this Onyx file is even more complicated than this H5. H5 I only have 2 success by myself. Usually people borrow from other library, but other people's library could be biased and you will mess up your case. So my teammate handled it really well. But so for now, I'm just gonna talking about my contribution on this small micro project. So the main step in the process is cleaning data and uses. This is my friends doing it, my teammates doing this type of things. They handle it really well. And then text to speech, Rigobert will do it really well. We have different formatting, and I'm using Max Native. So now we have backup plan. My backup plan was to using Unity developing this number recognition system. So we start from basic number to hand to video to audio and integrating all of them together. So now, what does our first prototype do? Our first prototype is input. We capture using this media pipe for this finger points. and then we learn these finger point patterns. So what's the potential from this basic prototype? It can, of course, it's learning a sign language, having people with disability, and also for music, this sign language can help us learning conducting patterns, and also for gaming, we can use this gaming hand controller, and for new music art project, some people already come up with these things, and also can anti-stress, just play for fun. Like I developed a game, we'll show you later. So H5 versus Onyx. There are two different formats. One was H5, one was Onyx. So the H5 hierarchy data format was using this TensorFlow Kalias, and Onyx was like mostly with Unity, Barracuda thing, but it didn't work. So I'm mostly using H5 in this case. The solutions and the steps focus on cleaning data and testing real-time integration, and then refining the text-to-speech, and then you're using Unity, and finally you test with Flask. Flask is also Khugzhem's idea. Like Khugzhem was really great at so many great things. We learned so many good things from him. The Unity setup Barracuda was something I failed. I want to try more because Unity was better than other platforms. This is the Barracuda testing. And H5, what is H5? As I showed you before, H5 is called hierarchy data format. These things they're reading through different formats, for example, CVS, and also the PHY things, like I showed you before, the two-dimensional things. I call it like that. The use case is commonly used for TensorFlow and Kalias. And also they can store different neural networks, weights, and training figures. The Onyx format was better for Barracuda and also using AI PyTorch, TensorFlow, and different platforms. So how do we convert in between them? We're creating a code converting between H5 and the Onyx. Optimization, these things is also good with GPU and mobile things. There are also other formats. How do we converting different formats? We're converting from H5 to Onyx using this bus, not using this pip install these things, and then we copy paste the code like this, put the code like this, the towards Onyx export model input tensor model Onyx, and then we creating a converter, converting these things into the other formats. But these things always fail for me. I don't know why, but in the future we'll continue exploring. The Flux was Khugzhem's best idea, so I'm learning so much with this Flux. I'm going to show you really quick later. As I show you, I'm going to tell you how I set up this Flask. So basically, Flask app was like deploying a Flask app using different platforms. So my solution was using Render, and my teammates also have this kind of like Streamlit Hugging Face things. Now let's test in different platforms. So let me close one of them first. Yeah, first, let me show you about this basic testing system. First, we test if this handshaking thing is working or not. Wait. This shouldn't supposed to be like this. Alright, we'll show you another one. Sorry. So for this project, Yeah, this project will show you this, will have generating a different formats, and they're playing a guessing game with you. For example, this hand sign is the math, and this is the fu, and this is the math. So they were playing something similar to this scissor rock with you, and then they will randomly generate something. And so I also trained these things one by one with using this media pipe to recognize the different hand marks, and then I make 150 different pictures through learning these things. So this is my unique design on this, similar to this model pattern recognition system. Now let's show. Sorry, my computer is a little bit slow, so these things will be really unstable. For example, I'm using math.
You choose a mice. You win.
Give it a
You
second.
choose
See,
a mice.
they will say mice is 0.75%.
It's a tie.
And then they will randomly generate something
choose
to
a
see
mice.
if you win or not.
You win.
Now let's do hand. You can even move your hand like
You
this.
choose the fool.
Now I choose the fool.
Computer wins.
Give it a little bit of time.
You choose
yeah,
the
see,
fool.
100%. This is easy
You
to
win.
recognize. This is just a peace sign.
You choose
and now we
the
have a
fool.
cat. Let's see, the cat was the hardest
It's a
one because
tie.
you have a curving finger. Now they choose
You
that.
choose a cat. Computer wins.
See?
You choose a cat. It's a tie. You choose a cat. You win.
Yeah, this is basically what happened. I'm stopping it just in case it's draining my computer. And they were generating here. So now for the last part, I would like to show our final project at the presentation night. And thankfully, my teammates Rigoberto and Marco Chen and me was working on these things. So for the last, I would like to show our recapitulation for Marco Chen's work. So here is Marco Chen. Sorry.
Okay, now let's introduce our project. You can say something.
So actually our project is related about the computer vision, about on the data science. So basically we use the medium pipe, which is open source library from Python, which is related to the computer vision recognition. So it's providing a model that we can use our own data set to train it to recognize different labels. So based on those labels, we put in the JPEG pictures or MPG picture in those labels and then put in the model to train it. After we train, we can also decide like how precise we want, and also we can well-tune the model in the future to recognize more size. But for this project, now we did is we train it, we use the data set, the ASL side, we train it into A to C to recognize all that kind of alphabet. So now I'm gonna show a demo on here on my solos. So I'm gonna start the live camera feed. So basically, so we have a side here. Can you side? So first of all, we put our hands. There's a landmark detection on the finger. So it has like 21 point. Cardiacs on your hand to recognize it's a handshake.
Yeah.
Definitely you can do it like face shape, something like that. But now I can try to do a hand side to let the model recognize my sign language. So I do the A. So it gives the decided read, and also how confidence, how precise a model recognize. Okay, and then let's try two different sign now. Okay, okay. I think I shouldn't. Okay. This is. This is A.
S.
No, this is not S like this.
Yeah.
This is E.
Okay.
This is E. This is A. This is A. Okay.
Nice.
This is B. If you close the finger, that will be U. Okay.
Oh, that's
U.
nice. Yeah.
Okay. And then if you make your finger cross, that will be R. Okay. Yes, sorry. And you can try to V. V. And then three finger is W.
W? Okay, that's great.
The letter will only keep the record of the change count. If your size keep the same, it don't record. So try to keep like less memory. Okay.
Thank you. That will be all. Thank you for watching our video. Hope you enjoy. Have a nice day.